Hey everyone, and welcome! Today, we're diving into a really fun explainer to completely demystify the absolute magic happening right under the hood of your car. For a lot of us, an engine is just this big, loud, vibrating metal box that makes the car go forward, right? And, when it makes a funny noise, we usually just turn up the radio. But today, we're breaking it all down. We're going to look closely at the anatomy of a healthy engine, and then we'll learn exactly how to diagnose it when it gets sick. Here's our anatomy to pathology roadmap. We're going to cover the engine's core mission, map out its anatomy, and walk through the four-stroke cycle. Then, we'll pit gasoline against diesel, check out the engine's survival systems, and finally, wrap up with diagnostics and breakdowns. Because to fix a sick engine, you really have to know how a healthy one works first. All right, let's jump right into section 1, the engine's mission. I actually want you to forget everything you think you know about cars for a second. Seriously. Strip away the tires, the steering wheel, the fancy touchscreen. At its absolute core, an engine has one violent, beautiful purpose. It operates on what I call the golden equation. Fuel plus air combined with compression, ignited by combustion, equals movement. That's it. Every single piece of metal, every wire, every drop of oil inside that block exists just to execute that one mathematical reality. The engine doesn't actually push your car. It creates rotation. It turns a literal explosion into a spin. Which brings us to section 2, engine anatomy. To really get how this machinery handles those explosions, try thinking of the engine like a complex, living organism. It's got a skeleton and organs. Let's isolate two foundational terms that can sound a little alien if you're new to this. First, the engine block. Think of this as the body. It's the massive, heavy structure, usually cast iron or aluminum, that houses the cylinders. Second is the crankshaft. This is the primary axis. Its whole job is to take the violent up and down motion from the engine's internal organs and translate it into a smooth, circular rotation. So how do these organs connect? Well, you've got the piston, which takes the literal blunt force of the explosion and gets shoved downward. But for an explosion to happen, the piston needs to breathe, right? Enter the valves. These are the mechanical doors letting fresh air in and pushing burnt exhaust out. Then we have the connecting rod. This acts like an arm, linking the pushing piston directly to our crankshaft. And finally, the timing system. This is the brain of the whole operation, making sure the top half, with those breathing valves, and the bottom half, with the pumping pistons, are just flawlessly synchronized. Moving right along to section 3, the four-stroke cycle. Now we get to see this organism actually breathe. This is the heartbeat of automotive engineering, and this specific loop repeats thousands of times a minute. Step 1, intake. The piston drops, the valve opens, and it aggressively sucks in air and fuel. Step 2, compression. The valve slams shut, the piston rises, squeezing that mixture into a tiny, highly pressurized space. Step 3, combustion. Bang! The spark ignites, creating a massive downward force. And step 4, exhaust. The piston pushes back up, shoving the burnt, useless gases out the tailpipe. Suck, squeeze, bang, blow. Over and over and over again. Let's look at section 4, gasoline versus diesel. Here's where things get really fascinating. There's a fundamental split in how this heartbeat works depending on what the car drinks. A gasoline engine needs an electrical spark. It uses a spark plug to literally electrocute the fuel mixture and start the fire during that combustion phase. But a diesel engine? No way. It doesn't use a spark at all. It relies purely on extreme pressure. It squeezes the air so incredibly tight and so fast that the air gets superheated. When the diesel fuel is injected into that blistering hot air, it violently auto-ignites, all on its own. Okay, section 5, survival systems. Containing thousands of violent explosions a minute generates a ridiculous amount of heat and stress. So while an engine is tough, it's also incredibly needy. It has 6 absolute survival pillars. Think of these as its blood and sweat. It needs air to breathe, fuel to burn, compression to squeeze, synchronization to keep its rhythm, lubrication to stop metal grinding on metal, and cooling to keep from literally melting. Remember these 6, because if even one of these pillars fails, the entire organism collapses. And speaking of collapse, I really need to slow down and emphasize this next point. That little red oil can light that pops up on your dashboard, that is not a suggestion. It is an absolute emergency alarm. Driving without oil pressure means metal is scraping against metal at thousands of revolutions per minute. The friction and heat are catastrophic. Driving without lubrication is an instant death sentence for your engine. You pull over safely, and you turn it off immediately.
Which perfectly sets up Section 6, Diagnostics and Common Breakdowns.
So we know what a healthy engine looks like. Now we're pivoting into the world of pathology. What actually happens when the engine fails? From here on out, I want you to put on your detective hat, because diagnosing a sick car isn't about wildly guessing. It's a mechanical detective story. Let's say we're missing just one of those 6 vital needs we just talked about, specifically compression. If a cylinder can't squeeze the air tightly anymore, maybe because the internal rings are worn out, you get this massive cascade of miserable symptoms. The engine becomes incredibly hard to start. It feels super weak when you step on the gas. It vibrates weirdly. It starts eating its own oil and blowing smoke out the back. See? One single failure, but a whole host of clues. And brilliantly, a good mechanic reads that tailpipe smoke the exact same way a doctor reads a patient's temperature. Black smoke, the engine is running rich, meaning it's drowning in fuel or starving for air. Blue smoke, that's a clear sign internal oil is somehow leaking into the combustion chamber and getting burnt. And what about thick, sweet-smelling white smoke? That usually means the engine's cooling system has breached the cylinder, often pointing to a blown head gasket.
But here is a massive trap for beginners. Do not confuse a symptom with a part. Blue smoke isn't a broken part you can just go buy replacement for at the auto parts store. It's merely a clue. The actual failed component causing it could be worn piston rings, a blown turbocharger, or bad valve seals. We have to follow the clues to find the root cause.
So how do we actually hunt down that root cause? Logic. We use a strict diagnostic logic sequence. We systematically test those core survival needs to eliminate suspects one by one. If a car won't start, don't just throw expensive parts at it. You ask the questions, does it have air? Yep. Does it have fuel pressure? Yes. Does it have good compression? Yes. Is the timing synchronized correctly? No. Okay, boom, we've found our suspect. You rule things out until the culprit is cornered. And this brings us to our final thought for today. If you don't truly understand the 4-stroke cycle, intake, compression, combustion, and exhaust, you will never be able to properly diagnose a car. You'll just be memorizing lists of symptoms without grasping the beautiful mechanical logic behind them. But now you know the mission, you know the anatomy, and you know the vital systems. The next time you hear a strange knock or see a puff of smoke, you aren't just guessing anymore. You have the foundational knowledge to open that hood, look at that incredibly complex organism, and start asking the right questions. So what do you say? Are you ready to be your engine's detective? Thanks so much for joining me on this explainer, and I'll catch you next time.